So at this point, you've done some problems. You're feeling pretty good about it. I'm going to give you these notes, the toolkit notes. So go ahead and get the toolkit out. I'm going to do this, and then we'll go to the examples. But now is a good time to do this. So just to kind of like refresh, like, okay, where are we at? So differential equations are any equation that contains a derivative. We talked about that before. We have seen many of these before, and we've usually computed them by taking the general antiderivative. However, there's a way to solve a differential equation by separating the differentials, which is what we've been doing, um, and then integrating. Okay, so here we go. We know what to do, right? So separate the differentials. You multiply left and right by dx here. I'm gonna get a pen because this is a bit of a. I'll rewrite it. So we say dy dx equals 7y yx, and we'll multiply both sides by dx. And we will have to, in this case though, this is where things get a little bit different. We have to divide by y, right? Because I'm having to divide by y because y is being multiplied by x, so I have to cancel them out that way. In this case, they always cancel top and bottom, but sometimes you might have to divide rather than multiply. So this simplifies to dy over y equals 7x dx. Good so far? Yeah, makes sense. So those just combine the terms. Separating the terms. Then we will integrate both sides. Okay, so we're going to take the integral of dy over y equals 7x integral 7x dx. So when you do that, well, let's do the right first. We're just going to get 7x squared over 2 plus c. And on the right, we're going to get ln absolute value of y. Here is where things are gonna get a little complicated. So in this case, there's two options you can do, and in this case, we don't have an initial condition. So I'll talk about that in a moment. But to get this y alone, at this point, we have to get the y alone, right? So in order to do that, um, you need to do what's called exponentiate. And to exponentiate, you're raising e to the power of both these equations. Um, and so when you do that, um, the ln and the e cancel, so you just have y equals e to the power of 7x squared over 2 plus c. You follow that? Um, from here, and I'll do more examples that show you like what's going on here. This is the same as y equals e to the 7x squared over 2 times e to the c. And I just want to pause to make sure you understand this. This is using the rules of exponents. So say for example you had like x to the pi plus 1, for example. That's really the same as x to the pi times x to the 1. It's just like rules of exponents say that when you multiply two bases with this, um, you add their exponents together. So that's what we're doing here. And so because e to the c is just a number, right? E to the c is number, that's a number. We can put in the, this is something. This is some number. We rewrite it as y equals c e to the 7x squared over 2. Okay. Um, you don't have to do this method, and I'll show you like the alternate one that delta does. Delta doesn't do it this way, but this does. Like this method appears in the AP test, and you have to know kind of what's going on. You'll see this, so I want you to be familiar with it. It's not like magic. Um, Another thing is that this C right here is different than this C. They're different C's, which also makes things confusing. Um, but this is the general notes, and so this is the general solution. Again, general solution. Let's do some problems. So let's go back to um, those problems, and I'll show you, how that works in a delta problem, for example. So we know that f of 1 is 2, and you need to change your problem, by the way. It's going to be y minus 3 right here. This is wrong. It should be y minus 3, so make sure you change that in your worksheet. dy dx equals 3x squared y minus 3. Okay, let's full screen this, and let's do it. Okay, so normal stuff. Multiply by dx both sides. Multiply by dx. Divide by y minus 3. Y minus 3. Divide by y minus 3. Okay, and things are going to cancel. The dx's cancel. The y minus 3's cancel. So I have dy over y minus 3 equals 3x squared dx. Next step, we're going to integrate. Integrate both sides. We're going to get on the right just x to the third plus c. And on the left, we are going to get ln absolute value y minus 3. And the absolute value is really important, and you'll see why in a second. Okay, and again, whenever you integrate, you always can say, okay, is that right? Is that ln y minus 3? Well, yes, because if I take the derivative of ln y minus 3, I get 1 over y minus 3. And this is the same thing as 1 over y minus 3 times dy. Like, these are the same thing. So just to be clear. Okay, so now we get to this stage, we can solve for c. And this is where I want to show you the kind of two different methods. This is the way that delta does it. And this is the kind of AP test method. Okay, there's two different methods that they kind of use here. The delta method does it this way. They're just going to, right now, they're not going to do anything. They're just going to plug in the 2 and the 1 into the equation. They're going to get this. ln absolute value 2 minus 3 equals 1 to the third plus c. And so what you'll get here is ln absolute value of negative 1 equals 1 plus c. Absolute value of negative 1 is just 1. So it's just ln 1 equals 1 plus c. ln of 1 is 0, right? It's an important one to know because e to the power of 0 is 1. So we say 0 equals 1 plus c. So then minus 1 both sides, c is negative 1. That is how delta will do it. Nothing wrong with that. But then you are going to plug this negative 1 would go right here. That's really important. The way that the AP test likes it is at this point they actually exponentiate. They don't solve for c right now. What they do is they say, okay, well, we'll do it like this. We'll do ln y minus 3, I'm just going to rewrite it, equals x to the third plus c, and they will exponentiate at this point. So say e to the power of, and these will cancel. And so you'll get y minus 3, that absolute value can go now, equals e to the x to the third plus c. Then using the trick that I just gave you here, they bring that c out front. So then just rewrite it as y minus 3 equals c e to the x to the third. Okay. Then they'll solve for c by plugging it in. So they'll plug in the 2 and the 1, so they'll get 2 minus 3 equals c e to the 1. So that's negative 1 equals negative 1 over e equals c. I just did 2 minus 3 is negative 1, and I divided both sides by e. So negative 1 over e equals c. And I think, okay, well, how come I got two different answers here? You got two different answers because they're going into two different equations. Because this one is going to go back into this equation right here, whereas this negative 1 goes back into the original equation up here. Does that make sense? So then we plug them in, we're actually going to get the same thing. So on the top one, we'll get ln y minus 3 ln y minus 3 equals x to the third minus 1. And then on the right, I will get y minus 3 equals negative 1 over c, negative 1 over e. It looks so much like a c. Negative 1 over e, which is, yeah, well, I'll get to that in a second. E to the x to the third. When I simplify this, I will get y equals e to the x to the third minus 1 plus 3 negative. Okay, got it. I don't know if you see that. I'll come back to that. Let me address this one. The reason that I think that they do this on the right is because this avoids the absolute value situation, because now we have an issue with the absolute value. Because when I put in a 1 in here, I'm going to get a negative number. This is where we have to use the properties of absolute value. This is not actually y minus 3. This is ln of negative y plus 3. And when you exponentiate, you're going to get negative y plus 3 equals e to the power of x to the third minus 1. I'm going to come back to this. I'm going to rip this so I can move it up. And I can explain more. One thing at a time, guys. E should go here, E should go here. I'm showing that I'm exponentiating. Then when you get y alone, you will get, when you move y over here and move the E over, you're going to get the same thing. You're going to get y equals negative E to the x third minus 1 plus 3. The exact same thing as this one. You might be wondering this one, well, how did you get from there to there? Let me show that simplification. So y minus 3 equals negative 1 over e to the x to the third. Negative 1 over e is the same as negative e to the negative 1 because it's on the denominator. So then that's negative e to the negative 1 times e to the x third. Then you're just adding those together. You get negative e x to the third minus 1. Then you added that 3 over plus the 3. Y equals that. So I'm going to recap from the top of these so that you understand from the very beginning. Okay. You get the dx's with the dx's, you get the y's with the y's. You integrate. You have your two antiderivatives. Then you have two options. Number one, you can just plug in your coordinate right now. One of the two go in. They go right in. Okay. The problem with, and we'll get to the problem with that in a second. You get your c. That c goes back into the original one. We have this new equation right here. Okay. That's one method. The other method is you rewrite this one, you exponentiate it now, and then you solve for c. Okay. So what's the pros and cons between these two? Well, I think the pros of the delta one is that it's very, very easy, like straight into it. You just plug it in, you get the value, you're good to go. The one on the right, a little bit more like finicky, like you just have to know to put that c in front, and that makes it a little bit more challenging. But what you do benefit from this right version is that you don't have to deal with absolute value. Absolute value goes away, but on the left it does not go away. And if you didn't catch that this absolute value trick, then you would get this left side wrong. You're going to get it wrong in delta. And again, the trick with the absolute value is because when I plug in a 1, remember your coordinate is 1, 2. If we go right here, if you plug in a 2 here, rather, you plug in the 2 for y, you get negative 1. You see that? I can't get that. Like that shouldn't be. I shouldn't be getting negative 1. I need to get a positive number. So the way that you counteract that, this is what absolute value means. Absolute value means it can be this, or you can make it negative, the whole thing negative. So if I'm getting a negative value and I plug in a 2, then I have to make the whole thing negative to counter that. And that's why we end up here.